In this video, we're going to cover mathematical set operations. So these are different operations you can do with two sets. So this is somewhat similar to the operations you can do with two numbers. So let's think about that for a moment. So when you have two numbers, you can use the arithmetic operations such as addition, subtraction, multiplication, and division to produce a new value. So you just place the operator between the two numbers, like a plus sign, a minus sign, a multiplication or division. We also learned about exponentiation, floor division, modulus division. So we learned about a few more operations. We also learned about the comparison operations. So this is somewhat similar with sets. We're going to have two sets, A and B, and we're going to do these set operations. So these are different than the arithmetic operations. And in fact, for the most part, they use different characters on the screen. They have different symbols that will complete the operation. So the four main operations we're going to learn about are the following here: union, intersection, difference, and symmetric difference. So just like with numbers, where a new value is created, like 3 plus 4 is 7, all of these operations are going to create new sets. And they're all going to involve these two sets over here, A and B. So A is all of these numbers, 1, 2, 3, and 4. B is the numbers 3, 4, 5, and 6. So we do have some overlap over here, and we have some unique ones to each set. So in Python, the way we're going to create these two sets is as such. So we create two sets, A and B, 1, 2, 3, 4, 3, 4, 5, 6. And then we're going to find the union of two sets. That's the first operation. We're going to use this pipe character. So this is a new character. So A pipe B, hopefully you can find it on your keyboard. And this will be the union. So the union is all elements of both. So everything that you see here, if you're just looking at the Python code without the diagram, you might think that 3 and 4 will end up in there 2 times. But as we know, sets only have unique values. So when we do this, this creates a new set. It doesn't change any of A and B. This is the union, so all of the elements in both sets. So A and B remain unchanged. You can also do this with the union method. So A dot union B, like this. So sets access their methods just like every other object. That's with dot notation. And we get the same exact answer. All right, now let's look at the intersection between two sets. These are only elements, these are elements common to both. So if we look at our diagram, this is that inner piece right here. So 3 and 4 are in both. So let's go ahead and see this. The way this is done is with this ampersand. And you can see here, this creates a new set, 3 and 4. You can also use the intersection method, like this, A intersection B. And that will get you 3, 4. All right, the difference of two sets. So this is where, and maybe we go back to the diagram, is where you subtract. It's basically sort of like subtracting. So we take out the elements of one that the other has in common. So if we do A difference B, we'll have all the elements of A, and then we'll remove any that are in common with B. So that's 3 and 4. So we're left with 1 and 2. And let's see that in action. So A difference B. This is one that uses the subtraction sign. So this is where there's some overlap between addition or between the numbers and arithmetic operators. So A minus B is 1, 2. Now B minus A is going to be different than A minus B. So we're going to get 5, 6. And when we go over here, 5 and 6 are unique to B. So it just pulls out, it removes elements that are in common with the other set. So in general, this will hold true. So A minus B does not equal B minus A. The order matters here. And you might be wondering, is there an A plus B? No, there's actually no plus for sets. That's just not how they work. Usually, sometimes it's easy to think, all right, well, if subtraction worked, then plus should work. Well, no, sets use the union operator, which is this pipe character, in order to combine all of the elements in both. So that does not work. All right, symmetric difference. So this is the last one we're going to cover. These are all elements unique to each. So if we go back up here and look at our diagram, 1 and 2 is unique to A, 5 and 6 are unique to B, so that's what it'll return. So it'll just remove the intersection, essentially. So it'll return 1, 2, 5, and 6. And the way we do this is with this caret operator. So A caret B is 1, 2, 5, 6. Here the order does not matter because these are just saying unique to each. And then there is a method in symmetric difference. And that'll give you that. I just saw up here, I did not do the method. So A difference B will give you 1, 2. All right, so those are the 4 operations you can do. So union with the pipe symbol, intersection with the ampersand, difference with the subtraction sign, and then symmetric difference with this caret. And then you can also use the methods. All right, so that is working or doing mathematical operations with sets.